All right, so the Chapter 6 retake review, I'll go through the problems that are going to be on the test. 1 and 2, I did not put in graphs on the test, so we'll skip that for now. When I go to these problems, there are 3 problems like this on the test, so let's go through them. The first 3 are dealing with laws of exponents. So here's what you need to know. You need to know if you're multiplying like bases, so these all have e's in them. So when you're multiplying like bases, you add the exponents. When you're dividing like bases, you subtract the exponents. And if you have a power that's raised to another power, you multiply the exponents. So those are all just the properties from last chapter. So here we can take, remember this all means multiplication, 5 times e to the third times 2 times e to the 5th. So we can multiply in any order. So I'm going to take 5 times 2 is 10. And then when I multiply the e bases, I keep the base. I add the exponents. 3 plus negative 5 is negative 2. Okay, so all I did is I multiplied 5 times 2, and I kept the base of e. I added the exponents to get negative 2. Remember, you can't have a negative exponent, so I have to take that e to the negative second, and I have to flip it into the denominator. So that becomes 10 in the numerator. That stays there. This base has to go to the denominator. I get e squared. All right, so if I have a power to a power, I have a product to a power, so I take 3 squared. 3 squared is 9, so you do have to make sure you square the 3. And then when I take e to the negative 5th and square it, again, a power to a power, I multiply the exponents, I get e to the negative 10th. So 3 squared is 9, e to the negative 5th squared is e to the negative 10th. Negative exponent, I have to get rid of that, so I bring that to the denominator. All right, now 5 is a combination of things. You can really do it in any order you want to. I would probably multiply the numerator first. So we do the multiplication. 6 times 2, and then when I multiply the e bases, I add the exponents. All right, now we're going to do the division. 12 divided by negative 4 is negative 3. E to the 10th divided by e to the 3rd is e to the 7th, because I'm subtracting the exponents. Now the 3 is negative, that's okay. You can have a negative number, you just can't have a negative exponent. All right, and then these, remember, we are just going to be worth 1 point. It's really just knowing that if you have a log of a base and then a base raised to a power, if the bases are the same, the natural log of e to the 7th is just 7. You're just really asking yourself, e raised to what power gives you e to the 7th? 7. These are a little bit more complicated. 7 raised to a log power, but again, if the bases are the same, your answer is just 4. Here we have e to the natural log, which is base e of 4x, so my answer is just 4x. So really, we talked about why that works, but really all you need to know for the test, it's only worth 1 point, that you know that if you have e and it's raised to a log base e, then you know it's going to be equivalent to whatever you're taking the log of. Okay, that's only a 1 point question. These up here are worth a little bit more because there's multiple steps to them. All right, and then the converting. Again, converting is probably worth 2 steps, I believe, just making sure you put everything in the right spot. So remember, your base of your log is the base of your exponent. So 4 is my base. Raised to the 7th power, whatever the logarithm equals, is your exponent. So 4 raised to the 7th power equals x. So just make sure you can do that converting. This one, my base is e. So log base e. I can either write it like this. I'm okay that you write it like that. Log base e of x equals my exponent. Remember, the logarithm always equals the exponent. So log base e of x equals 5. I would prefer you write it as natural log of x equals 5, because log base e is the natural log. And again, here this is an exponential. We'll put it log base 3 of 28 equals my exponent. So the logarithm equals the exponent. Log base 3 of 28 equals x. And that's all you have to do. This is non-calculator. You're not solving it. You're just coming up with the different form. All right, and then number 12 through 14 is evaluating the logarithm. So here we're looking to see, if you need to, just set it equal to x. I'm looking for the value of x. put it in exponential. My base is 5, raised to this power that I'm looking for equals 1 over 25. Well, 5 squared gives me 25, but again, to flip it into the denominator, x has to be negative. So it's negative 2. 5 to the negative second power is 1 over 5 squared, or 1 over 25. So it's just knowing your laws of exponents and what a negative exponent means. Log base 8 of 64. You're really asking yourself, 8 raised to what power gives me 64? Well, 8 squared does. So I know the log base 8 of 64 is 2. Log base 9 of 1. I'm really trying to figure out 9 raised to what power gives me a 1. So my base is 9. 9 to what power gives me 1? This one was a little tricky for some people, but anything raised to the 0 power is 1. So anytime you take the log of 1, you should get 0. Now I could do something like log base 7 of the square root of 7, or the cubed root of 7. Log base 7 of the cubed root of 7, you're saying 7 raised to what power gives me the cubed root of 7? Well, 7 to the 1/3 power. So x is 1/3. So then you have fractional exponents. So know all of those things of, if you have a radical, then it's a fractional exponent. If you have 1 over something, so that you have a fraction, then you're going to have a negative exponent. When I go to grade these, I do grade that, do you at least know that that's what you're looking for, or here that you know this. If you don't get that it's negative 2, if you think it's 2 or your guess is wrong, I'll at least give you the point that you knew that's what you were looking for. So make sure you show me that step in case you mess up, what kind of an answer that you're looking for. Okay, that's the front. On the back is the inverse. The inverse problems, remember, I give a point that you first just get it into, you switch the x and the y. That's what an inverse is. So I switch the x and the y. I now have to solve for y. So I need to get this 3 to the y by itself. So I add 1. I need to get y by itself, so I have to use logarithms because it's in the exponent. So I'm going to take log base 3 of all of this, so I need to put that in parentheses, equals my exponent. There's the answer. So I switch the x and the y, and then I just have to solve for y. So I have to get the base by itself and then put it in log form. Do the same thing with 16. My base is e. So I first am going to switch x equals natural log of y plus 2. So I switch the x and the y. My base is e. So I'm going to say e raised to the x equals y plus 2. So I'm converting it to exponential. E raised to that power has to equal y plus 2. To solve this for y, I just subtract 2. Now I can't put them together, so I just have to leave it as e to the x minus 2. All right, and then the last one. Switch the x and the y, because I'm finding the inverse. It's in exponential. I've already got the base by itself, e to this power, but I need to solve for y, so I need to put it in log form. So log base e, which is natural log, of x equals my exponent. So log base e, natural log, of x equals 3y minus 4. How do I solve? I have to add 4. So it's 4 plus the natural log of x. And I have to divide by 3. So y is going to equal 4 plus the natural log of x all over 3. So once you switch the x and the y, you have to solve for y, which means if it's in exponential and you got the base by itself, you have to put it in log form. And then you have to undo things to solve for y. If once you switch the x and the y, you got the logarithm by itself, now you need to put it in exponential form, and then you need to solve for y. Now the only other one that's on the non-calculator, so none of these are on the non-calculator. The only other one that's on the non-calculator I'll do on the next video is numbers 37 and 38. I did put those on the non-calculator. So that's that for the non-calculator.